Black holes, the mere mention of these phenomena in the universe can send shivers down the spine. People have long been fascinated by their mysterious appearance, wondering what is inside these invisible giants. As our telescopes and technology have advanced, we have looked deeper into the universe and discovered the terrifying truths about black holes. What if I told you that a supermassive black hole capable of swallowing the equivalent of the Earth every second is lurking in our backyard? Born from the death of the stars, these giants have an insatiable hunger and a power so powerful that no light can escape their grasp. But will any of these sleeping giants wake up? Could it be fatal for our planet? Can we walk away from a great disaster that we don't even fully understand? A black hole is bigger than a vacuum. The rest of a single-mass star compressed to a point of infinite density is known to be unique. This special situation is covered by the bar of failure, the point of no return where the light does not appear. The energy inside a black hole does not simply absorb matter. It is also a movement in space and time itself. Everything is held under unimaginable powers. Time, as we know it, bends and twists around these things, creating an unknown reality. The first image of a black hole was taken by the Event Horizon Telescope, EHT, confirming Einstein's theory of relativity that has long predicted the existence of these artificial beasts. But the more we learn, the more questions we have. How are black holes formed? What made them so big? And perhaps the most important question, can any of these global monsters threaten our existence? The idea of black holes came from Einstein's general theory of relativity, but for years the subject remained a mathematical equation. The idea is that anything can be so big and dense that nothing escapes the force of gravity. But with the improvement of surveillance equipment, the invisible can be seen. The first image of a black hole taken in 2019 by the Event Horizon Telescope is a major breakthrough in the universe. This massive object, located at the center of the galaxy M87, is the size of our entire solar system and confirms our understanding of black holes. But the discovery raised many questions. If black holes cannot be detected, how can we accurately determine their size, spin, and mass? These elements can only be measured through the indirect evidence left by their gravitational potential and the radiation emitted by the material that rotates them at incredible speeds before crossing the threshold. Despite our advances in knowledge, black holes are still shrouded in mystery and continue to baffle human understanding. The most terrifying aspect of black holes is their ability to devour everything in their path. Supermassive black holes, millions or billions of times the mass of the Sun, lie at the center of most galaxies, including our own Milky Way. These cosmic titans don't just absorb light and particles, they forcefully shape the fate of the galaxies around them. As gas and dust are drawn into their cores, the jets release intense radiation that affects star formation over millions of light years. One of the most surprising discoveries by the James Webb Space Telescope, JWST, revealed a supermassive black hole in the first universe, just 12.9 billion light-years from Earth. With a mass of 40 million times that of the Sun, this black hole swallows gas and dust at an incredible rate. The hypothesis here is that this black hole is eating away at the same time that the galaxy is forming stars in such a frenzy. This raises a deeper question: does the black hole help create new stars, or does the galaxy grow faster than the black hole's expansion? This chicken or egg conundrum is one that scientists hope will be uncovered in further studies of these giants of the universe. Not all black holes are active and not easy to detect. Many are alone, sitting quietly in the great room, waiting to be consumed. One of Gaia's latest discoveries is BH3, a dormant black hole located 1,926 light-years from Earth in the constellation Ophiuchus. With a mass 33 times that of our Sun, this black hole hasn't consumed enough material for years, so it's invisible. The European Space Agency's Gaia project discovered faint vibrations in a nearby star that indicate it's orbiting a large magnetic mass. Gaia BH3, now in hibernation, will awaken many more of these dormant giants that have never been seen in our galaxy. What would happen if one of these black holes suddenly got stronger? Is it a threat to Earth or other parts of the solar system? The discovery of Cygnus X-1 in 1964 was one of the first strong candidates for a black hole. However, there was a strong debate among scientists, especially between Stephen Hawking and Kip Thorne, two prominent experts in the field. For decades, they disagreed on whether Cygnus X-1 was actually a black hole, and Hawking was skeptical because of a lack of concrete evidence. But in 1990, Hawking admitted defeat and accepted that Cygnus X-1 was a black hole. Cygnus X-1 is one of the most massive interstellar mass black holes studied so far, having 21 times the mass of the Sun and orbiting at nearly the speed of the Moon. Its rapid rotation has challenged many current models of black hole formation and evolution, showing that we have only scratched the surface of our understanding of these mysteries. While supermassive black holes get the most attention, substellar black holes have their own interesting properties. SS433, located 18,000 light-years away from the Milky Way, is a microquasar, a smaller version of massive quasars that are fed by black holes. SS433 consists of a black hole 10 to 15 times the mass of the Sun and a white supermassive star. Working together, they create a powerful jet of matter that shoots out of the black hole at nearly the speed of light. Scientists are fascinated by these spacecraft because they emit gamma rays, energetic particles that may be part of the mysterious cosmic rays that bombard the Earth. Scientists have puzzled over the origin of cosmic rays for over a century, and SS433's relativistic jets may hold the key to the puzzle. By studying microquasars like SS433, we can begin to understand the mechanisms behind these powerful cosmic rays. As we look deeper into the universe with telescopes like JWST, one of the most vexing questions is the relationship between black holes and galaxies. Did supermassive black holes first form and seed the galaxies we see today? Did galaxies and black holes first form from the collapse of giant gas clouds? The discovery of black holes in the first universe, like the one found 12.9 billion light-years away, has deepened this mystery. The interaction between black holes and their host galaxies remains a topic of research. Black holes can drive the evolution of galaxies by pushing matter through powerful jets and controlling star formation. However, it is still unclear whether they play a more active or passive role in the formation of their galaxies. What we do know is that these giants of the world are connected to the growth and development of the world. As technology advances, we are approaching a new era in black hole research. Discoveries made by observatories such as the Event Horizon Telescope and the James Webb Space Telescope have revolutionized our understanding of these planetary entities, but there is much more to learn. Dormant giants like Gaia BH3 and powerful titans like the supermassive black hole at the center of M87 will begin. With each new discovery, the mystery of black holes deepens. Will we one day unlock the secrets of these cosmic monsters, or will they remain forever beyond our grasp, silently consuming all that crosses their path? As we continue to study the universe's most enigmatic objects, one thing is certain: black holes will continue to captivate and terrify, reminding us of the vast unknown that lies beyond the stars. One of the most profound consequences of black holes is their ability to warp the very fabric of spacetime. According to Einstein's theory of general relativity, the immense mass of a black hole bends space and time to such a degree that they become indistinguishable near the event horizon. This warping effect leads to phenomena like gravitational time dilation, where time slows down drastically for an observer near a black hole compared to someone far away. The closer you get to the event location, the stronger the effect becomes, until it feels almost real. This unusual behavior, when and where it falls on itself, shows a deep understanding of the nature of the world. Can black holes hold an understanding of the true nature of space, or lead to paths to other regions or planets? In 1974, Stephen Hawking revolutionized our understanding of black holes by introducing the concept of Hawking radiation. This radiation shows that black holes don't really collapse, they lose mass and energy over time by releasing particles close to the point of collapse. In billions of years, a black hole can completely evaporate, leaving nothing but radiation. This groundbreaking discovery linked quantum mechanics and general relativity in previously unimaginable ways and raised hopes for a unified theory of physics. However, Hawking radiation has never been directly detected, and its detection is one of the greatest challenges in modern science. If we can prove its existence, it will not only deepen our understanding of black holes, but also help us understand the fate of the universe itself, since black holes are the last to survive. As the world fades into darkness,